Okay, so today we're going to do a Thevenin equivalent circuit. We're going to use Thevenin. This is our Thevenin circuit. This is our load. The first thing we do with our load is we remove the load and put it in the Thevenin equivalent circuit, which is over there. So I'm going to remove this load. Okay? The first thing we do is we get VTH, which is the voltage from A to B. If you notice, this is open, so the voltage here is going to be 0. So if we get the voltage right here, okay, we have a circuit going like this, polarity. We can use the voltage divider rule, 16 at an angle of 0 times 450 at an angle of -90 divided by this and this, because really all you have is this series circuit. 450 at an angle of -90. When you do that calculation, you shall get 7.84 volts at an angle of -60.64. So that's the voltage for this component. So now when you go voltage A, you just have to start at A and you go to B, your VTH or voltage A to B is 7.84 and it's positive. So we go to our Thevenin equivalent circuit and we put positive, negative, because that's the direction it's going. And it's 7.84 volts at an angle of -60.64. Okay, so that's our VTH. Then we have to get our ZTH, which is basically Z total. With your original circuit, okay, you short batteries, you open currents, and you minimize the circuit. You put a fake battery here, okay? So you would have 800, these two are in parallel, with 450 at an angle of -90, and I did not do that calculation, but that's okay. So I'm going to put 800. We do the shift reciprocal because it's going to be in parallel, and then the 450 at an angle of -90, and make sure that you put your parentheses in if it has an angle. So when you put those in parallel, you get 392.21 ohms at an angle of -60.64. Okay, so that answer would be here. And it would be in series with this 350. So we're going to add 350 ohms plus 392.21 at an angle of -60.64. So let's add them together, 350, and we get 641.04 ohms at an angle of -32.23. That is this original circuit minimized with the fake battery where the source is. So this is our VTH, and this goes in our Thevenin equivalent circuit as VTH 0.04 at an angle of -32.23. Now the last step with Thevenin is to get the voltage across the load within the Thevenin equivalent circuit. So what can we use? We can use the voltage divider rule, okay? We can use 7.84 volts at an angle of -60.64 times the load component, 200, at an angle of 90. And then divided by this plus this, so 641.04 at an angle of -32.23 plus 200 at an angle of 90. The voltage is 2.797, so I would make it 2.80 at an angle of 44.02 volts. This is my final answer. The because that's the voltage across the load within the Thevenin equivalent circuit. And that's it. Bye.